Hello students, and welcome back for our 12th lesson on the topic of thermochemistry. And the subtopic today is to determination of the enthalpy of neutralization. Enthalpy of neutralization. That is what we're going to discuss today. And so at the end of this class, you should be able to carry out an experiment to determine the enthalpy of neutralization. That is what you should be able to do. Now, in our learning today, for us to achieve that objective, we are going to carry out an experiment. And our experiment is to determine the enthalpy of neutralization of hydrochloric acid by sodium hydroxide. So we are going to use the following. One, the apparatus and the chemicals that we require. We are going to use 250 ml plastic beakers, 2 of them. So we'll be using 2 of them. We'll use a tissue paper. We'll also use rubber bands to secure the tissue paper. Then we need a thermometer to measure the temperature. We also need labels. We need a 100 ml measuring cylinders. In fact, I have 2 of them here. One I will use specifically for the base. This one here I will use for the acid. And then we need 50 centimeters cubic of sodium hydroxide. Then 50 centimeters cubic of hydrochloric acid. Those are the reagents that we are going to use. Let us go on with the procedure. Let us go on with the procedure. So the first procedure we are told, wrap a clean 250 centimeters cubic plastic beaker with a tissue paper. And then secure the tissue paper with a rubber band. So wrap a clean 250 centimeters cubic plastic beaker with a tissue paper and then secure the tissue paper with a rubber band. So I'm going to have my tissue paper and use it to wrap. Use it to wrap my beaker. That, and you know why we are doing this, is to minimize errors due to loss of heat to the surrounding. So we are trying to make sure that heat is not lost, or a very small amount of heat is lost. Yes. Then I secure it with my rubber band, like that. So that is done. Then we move to, I don't need that. Now we need to number 2. Procedure number 2, place 50 centimeters cubic of 2 molar hydrochloric acid into the plastic beaker wrapped in a cotton wool or a tissue paper, and then record the temperature as T1. Place 250 centimeters cubic of HCl. Place 50. So I'm going to have my hydrochloric acid. Then this one is what I'm going to use. And then we'll be measuring Yes, we'll be measuring 50. Yes, it is 50. And then transfer into the plastic beaker. After that, record its temperature. Record its temperature. So my solution is 26.0. So the temperature of the hydrochloric acid, is 26.0 degrees Celsius. Then we move to procedure 3. Using a clean measuring cylinder. I've used this measuring cylinder, so I don't need it. Using a clean measuring cylinder, measure another 50 centimeters cubic of 2 molar sodium hydroxide. Rinse the bulb of the thermometer in distilled water and determine the temperature of the sodium hydroxide as T2. So we are looking for T2, which is the temperature. We'll take the clean measuring cylinder and then measure 50 centimeters cubic of sodium hydroxide. centimeters cubic. Yes. Then after that I'm told rinse the bulb of the thermometer. And that's why I brought 2 beakers, because one was to rinse, so that we will remove the traces, all the traces of the acids which was here. Now it is clean. Okay? Then we are told, after raising the bulb, determine the temperature. We're going to have it there. This one is also. Yes, so T2, I come and record T2 to be 26.0 degrees Celsius. So this is T2, 26.0 degrees Celsius. After that, we move on to procedure 5, where we are told average T1 and T2 to get the initial temperature of the mixture. So average T1 and T2 to get the initial temperature of the mixture. So T1 and T2. T1 is 26, T2 is also 26. Then we divide by 2. So the average initial is 26.0 centimeters cubic. Meaning we take solution A, sodium hydroxide and hydrochloric acid, then we average the initial temperatures. Move on. Now, number 6, procedure number 6. Carefully add all the alkali sodium hydroxide into 250 centimeters cubic plastic beaker wrapped in the cotton wool or the tissue paper containing the acid. Stir vigorously the mixture with the thermometer. Determine the highest temperature change to the nearest 0.5 degrees Celsius, T4, as the final temperature of the mixture. So we are told to add carefully this one here. And then stir vigorously with the thermometer, and don't stir the bottom of the container. As you stir, we are supposed to check the highest temperature. It has gone now, it is around 36. It is now 36, still 36. So far, we have reached 36. Still 36. So it has reached 36. So our the highest temperature of the mixture, which is T4, is 36.0 degrees Celsius. 36.0 degrees Celsius. Now, let's see the next thing. So that is the table. This one is the table that we are supposed to fill with data, and we have been collecting that data. So after the table, we have the first question. We are moving to the question. So question A, question 1, we have to calculate the first average initial temperature of the mixture. Already we have done it here. The average temperature of the two solutions, the mixture. So there we take 26 for the acid. Then we take 26 for the base. We add the two temperatures, divide by 2, we get 26 degrees Celsius. That is one. So our average is 26. Then the next question, the temperature change. Now the temperature change, which is actually question B, number 1B. The temperature change, we take the highest temperature, which is T4. Let's call it delta T. So temperature change, which is T4, or it is T5, should be given by T4 minus T3. So it will be 36.0 degrees Celsius minus T3, which is 26.0. So this one will give us 10 degrees Celsius. The temperature change is 10.0 degrees Celsius.